Okay, good afternoon. My name's Paddy Young. I'm Director of Enlit, and I'm here to welcome you to this press conference to the grid and beyond, how to secure the energy transition through innovation and energy efficiency. And we're delighted to have the International Energy Agency, IEA, Schneider and Enel here on the podium. I think if we look at the context of this, we have COP28 literally starting this week. We have the EU Grid Action Plan. We have the IEA's Electricity and Grids and a Secure Energy Transition report, which again created a lot of headlines in a lot of press, and then also a report that will be presented tomorrow. So we're actually having a little sneak peek of the IEA's Energy Efficiency 2023. So this is the context that we're in, and I think we're going to have a very interesting discussion around these topics. Two things that I'd like to highlight. The content is embargoed, so please keep everything within these four walls. 7 a.m. tomorrow morning, it will be released in Paris time. The other thing, everything that is said in a microphone will be recorded, so please, again, keep that in mind when going forward. So if we click through, as I mentioned before, we're delighted to have a fantastic opportunity here to hear these more about these reports, and then also to get a great response. So on the stage you'll see Brian Motherway, he's head of the Office of Energy Efficiency and Inclusive Transition at the IEA. Then we'll have Pablo Javier Koch, Head of Renewable Integration and Secure Energy Unit at the IEA. They will be presenting, and then delighted to have Frederick Godemel, Executive Vice President of Power Systems and Services at Schneider Electric, and Gianni Amani, Head of Enel Grids and Innovability from Enel. They will respond to these reports. So just a reminder, embargo till 7 a.m. Anything you say in the microphones will be recorded, and it's a real pleasure now to hand over to Brian Motherway.
Thank you, Paddy. Thank you, everybody. It's a pleasure to be here at Enlit. It's a real buzz around the conference, and it's really exciting to have this opportunity to present to you literally for the first time some new results we're sharing, which will go live tomorrow on the latest global trends around energy efficiency and energy demand at such a crucial time, just a few days before COP starts in Dubai, at a crucial moment for the planet around energy and climate issues. And we in the IEA will be at COP discussing many energy and climate dimensions. You'll hear about a couple from myself and my colleague Pablo, and we will be pushing for really positive outcomes there and sharing in advance, as I will with you now, some really important issues around what do we know about the global trends and what does that tell us about what we need to achieve, and that's what I want to share with you now. And as Paddy has stressed, what I'm sharing with you now, we are very keen to take this opportunity with our friends and partners in Enlit to give participants here an exclusive preview of what we'll be launching tomorrow, and our Executive Director Dr. Fatih Birol will be launching this tomorrow morning to the world. We thought we'd take this opportunity of the event today to share it with you, but we do ask then that you respect an embargo just till tomorrow morning. But happy to chat about it today and give you some special results in advance. Now, last year, when we report on energy efficiency trends globally, and this time last year what we said was 2022 seemed to suggest that something is happening in the world of energy efficiency, driven by a stronger focus on climate and clean energy objectives, but in 2022, particularly driven by the energy crisis we all found ourselves in, with a focus on energy prices and energy security. We saw a real push on energy efficiency around the world, and we said that maybe we're at the start of a turning point for energy efficiency, where we're seeing the beginning of a new dawn of a focus on energy efficiency and a real new focus around the world on driving it forward. 2023 saw something else happening, and that, of of course, is the hottest year on record globally. Well, right around the world, in every part of the world, we saw really extreme weather events causing very significant hardship, extreme temperatures, extreme flooding, and other weather-related events that really made people's lives difficult in many ways. And of course, people responded in many very rational ways, including looking for comfort from the heat they experienced. And for example, internet searches for buying air conditioners reached new heights. Air conditioner sales went up by more than 50% in key regions around the world. And energy demand related to air conditioning went up right around the world. We track this very closely, and there's a direct relationship around the world. When the temperature goes up, electricity demand associated with air conditioning goes up. In Texas, every degree above 24 degrees sees a 4% increase in electricity demand associated with air conditioning. In India, that's a 2% increase for every degree because not as many people own air conditioners. But it's going up every single year. More people are owning air conditioners, more people are using air conditioners, and we're seeing that happening right around the world. In the 10 biggest electricity markets around the world this year, in 2023, they all saw their biggest ever electricity peaks in the entire history, because in some of those regions, on the hottest days of this year, air conditioning accounted for nearly 3/4 of the peak electricity demand on the very hot days. So we see a real pressure there on energy systems associated with the hot weather. Are policymakers responding? Yes, they are, because now most air conditioners being sold have at least some efficiency standard associated with them, over 90%. Many other technologies have energy efficiency standards being applied. So we do see energy policymakers responding more and more. And in 2023, we saw a lot of that, a lot of policy being made where energy efficiency standards, regulations, codes, incentives are getting stronger. So we commend policymakers for responding in the right way, raising energy efficiency standards. But we see contradictory pressures as well, because we see energy efficiency policy and standards going up, but we see economic growth. We see lifestyle changes. I won't go into this in much detail, except to say if you look at a growth market like Brazil, where say people are used to live in multi-dwelling households, people are now building more houses, living in different situations. Even though those homes are becoming more efficient, energy use in buildings is actually going up for understandable reasons. In a more mature market like the United Kingdom, energy efficiency is actually driving down building energy use. Now, it's worth saying that that energy use in the home is 4 times as high in the UK as it is in Brazil. So we see catch up, but we see those kind of dynamics pushing up energy demand, even though energy efficiency is getting better, and that's playing out right around the world. So as a whole, we see energy efficiency improving, but we see economic pressures countervailing against that, and therefore, what are the outturns? Well, last year in 2022, the world became 2% more energy efficient, and tomorrow we will reveal how we did in 2023. I can tell you now it's a mixed story. Some regions got better, some regions not so much, but we know that for the rest of this decade, we need to double our performance. By the end of this decade, we need to be hitting about 4% a year. We know that that is possible. We know that most countries have achieved that double 4% rate at least once in the past decade, and in fact, half of the world's countries have hit that 4% rate at least 3 times in the past decade. So we know that 4% rate is achievable, but most countries are not achieving it in a consistent rate. And so our call for COP is to see countries commit to that doubling rate for the rest of this decade. That's one of our key asks for COP, is a doubling in the rate of energy efficiency improvement for the rest of this decade. If we achieve that, it'll be one of the biggest contributions to emissions reductions in the rest of this decade by 2030. We'll see energy bills going down, we'll see energy use going down, and we'll see 4.5 million more jobs in energy efficiency right across the world than there are today. It can be done. The technologies exist and the policies exist. We know that if we took all the best policies from around the world today and just applied them uniformly and well around the world, I show some example policies here. I could choose other ones. I just want to make the point that we know the policy solutions, we know the technologies, we just need a stronger focus on energy efficiency. From the kind of companies you're going to hear from today that you see around Enlit, we just need this focus on energy efficiency stronger than ever. Thank you for that. I'm going to now turn over to my colleague, Pablo. Thank you very much.
Thank you very much. It's really a pleasure to be here presenting some of the work that we've done recently. And thanks, Brian, for the excellent presentation. You really highlight how climate change is not something that we're looking towards in the future. It's something that's affecting our power systems today. And some of the work that I'm going to be showing is related to the role that electricity grids have to play in this changing world, and particularly in the changing world of electricity. So very recently, we launched a report that focuses for the first time on the topic of electricity grids and the role that they play in secure energy transitions. Now, this is looking at, of course, both transmission and distribution. As far as we know, this is a first of its kind global stocktake of the world grids. And the main question was, in the face of the changing world, in the face of the changing nature of energy systems and electricity, is it possible that electricity grids are becoming a bottleneck for secure energy transitions? And if so, what should be the pathway upon which these grids should develop, and how can we get there through policy action? Now, Brian very much introduced this changing nature in terms of the changes in energy efficiency coupled with a growth of demand. And indeed, we see that happening. And for accepting these new changes in demand nature, what we see is a need for an expansion and modernization of our grids. One central question is, how many grids do we need to meet the announced climate targets? Now, over the last 20 years, we have seen that grids have grown by more than 25 million kilometers, and this is remarkable. But if we are to be aligned with our climate targets, we need this to accelerate. We should be seeing that over the next 2 decades, grids need to expand in terms of kilometers twice as much. Transmission needs to expand to bring power from distant projects towards consumption centers. Distribution grids need to be there in place in order to serve new demand, in order to enable new distributed technologies and innovative technologies to take place and take maximum use of their advantages. Now, the story is not just about expanding grids, but it's also about dealing with grids that are becoming too old. So in addition, we see that 30 million kilometers of grids need to be replaced and modernized due to their age. So it means that in total, we're looking at globally 80 million kilometers of grids that need to be either expanded and created or modernized. And this is a significant length. This is roughly enough to wrap around the Earth 2,000 times. Now, how do we get from the situation today to where we need to be? And of course, one question is investment. What we have seen is that over the last decade, investment in renewables has been growing significantly. And this is great news. But unfortunately, we have not seen the same when we're looking at the investment in grids. While investment in renewables over the last decade has roughly doubled, what we see is that investment in grids has remained stagnant, around $300 billion per year. Now, if we are to achieve the growth and modernization of our grids in this decade, what we need to see is roughly a doubling in investment in grids, both transmission and distribution, so they are growing in lockstep with the growth of renewables. Now, what to note is that when we look at the growth that we've seen in the recent 5 years, this is not enough. At the recent growth rate, we're going to be falling short from the target of 600 billion. There's a significant gap that needs to be handled, and this means we need to accelerate development and investment in grids. Now, one question is, what happens if this does not take place? And I would like to highlight here that when we're looking at the growth that is needed in terms of transmission and distribution grids, this is not looking at trying to continue doing exactly the same approach that we've done over the last 50 years and an old power system. This is what we estimate is needed when considering improvements in energy efficiency, when considering a significant growth in digitalization in distributed technologies. Now, to study what happens if this acceleration in grid investment does not take place, we created a grid delay case. And the grid delay case is not a worst-case scenario. This is a scenario upon which countries around the world keep trying their best to decarbonize their power system. But the fact that grids are not ready has a significant impact on the integration of renewable energy. And that means that this will keep the global share of electricity from wind and solar PV almost 15 percentage points lower in the longer term. And let me be clear, this is a remarkable progress, but this will be devastating for energy transitions. Now, this would mean, of course, a significant impact on the consumption of fossil fuels, in coal, in natural gas. Not only will the consumption of coal decrease much less than expected, but the consumption of natural gas would actually grow over the period. And this means more CO2 emissions, but also significant more fossil fuel imports cost for the countries that depend on these fuels to provide their energy needs. From the perspective of emissions of the power sector, this would really have an impact on our ability to achieve the Paris targets. This means that compared to our unsplashed scenario, where the median growth is 1.7 degrees of global temperature by 2100, we would see a 40% chance of breaking the barrier of 2 degrees, which has devastating effects in terms of extreme weather events. As part of the report, we focused on 6 areas where we need to find action in order to accelerate and advance our grids. I'm not going to go in depth into all of this, but I would like to point quickly the fact that we need to be looking at integrated planning. We need to be looking at a forward-looking regulatory system that allows grids to be there when they are needed. Particularly, we're considering that high-voltage projects or ultra-high-voltage projects can take over 10 years to develop in advanced economies. Secure supply chains are going to be essential for this. And of course, when I'm talking about secure supply chains, I'm referring not only for the minerals like aluminum and copper, but also for all the elements of the power system that will be needed. That includes transformers, power electronics, electrical steel. Now, as I said, it's not just about expanding the grid length, there's also a need for modernizing and strengthening. And digitalization here will be key. What we're seeing is a need for enabling and deploying all technologies and solutions available. And distribution grids, in this case, will be essential for ensuring that distributed resources, that storage, that demand response can be effectively applied to support the power system. Finally, I would like to highlight the human factor. Today, we're seeing globally already a challenge for many companies and regulatory institutions to attract the professionals that they need in order to develop their projects on time. We need to make sure that the curriculum of educational institutions is adapted to the needs that we will have tomorrow. I would invite you to look a bit more in detail this report, and if you have any questions, glad to go into it afterwards. Thank you very much.
Super. Thank you very much. That was very, very interesting indeed. I think when I framed it, I was talking very much around the sector, but I think something just to add to that is that the issues around energy efficiency and certainly around grid is really now coming into much, much more into public domain. And I think just coming from the Netherlands, seeing how these things are now regularly featured in the newspapers. So I think the whole context is quite interesting when you have that element in there. So no, thank you very much for the presentations. And now I think I'd like to hand over to Frederick Godemel, please. Welcome.
I'm not going to use slides. Just going to comment a few points that was presented by the IEA. So basically, when you look at the energy transition, the equation need to be looked end to end, right? There has been a lot of focus on power generation, renewable, and so on. And I'm pretty happy that now the focus is starting to shift on what needs to be done at demand side, and of course, how you connect a renewable generation with the demand side and then the grid, right? And that's where your two reports are pretty important and push us to react. The first thing that we know is that the best energy sustainable is the one we don't use. Okay, so looking at energy efficiency has a huge effect on the entire chain. Keep in mind that if you are in a centralized generation model, if you save one at the demand side, you save two at the generation side, right? Because of the losses that you have around the chain, okay? So looking at energy efficiency is fundamental. That's a place where really we have seen that a combination of technologies, policies, and focus is bringing results. Now, as it was said in the report, not enough. Not enough renewal of buildings, homes, and so on, where today technologies are affordable with a return of investment, and I insist on that, with a return on investment. it's absolutely fundamental that we look at the energy efficiency. It's a fundamental parameter of the energy equation, and is probably the most easy to access by each and everybody. And I think in Europe, which is a place where we have developed countries, that's where we have to show the way. So in Europe, we believe that it's achievable to be every year in a place where we demonstrate a better usage of energy, because that's probably a place where those investments, compared to the price of energy, those investments have a return of investment, which is in a time frame of 3 years to 10 years. So basically, economically, it's accessible to now move to energy efficiency. So the first call is around energy efficiency, energy frugality at the demand side. Now, your second example is how you connect generation with demand. Okay? In all cases, even when you are extremely efficient, and even in buildings that are today net zero, and we have at Schneider Electric example of net zero building. We have one building in France with 2,000 people. It's a net zero building. So it's a great example of how energy can be saved. This building is connected to the grid because you're not permanently net zero. You are net zero over 1 year, but you're not permanently net zero. It means there is a moment in time where you need to be connected to the grid, right? So the grid is a fundamental element of this energy transition, because we want more electricity to replace fossil fuel, and then more electricity will require a reinforcement of the grid. The case presented here is really the case we don't want to have. And to solve this, and I'm sure my colleague will speak about that, we need to accelerate the investment in the grid. Accelerate it in all dimensions. With regulation first, because at the end it's a regulated environment where really the regulation have to favor. With, of course, reinforcement, which will be a mix of hardware and a mix of software, because the technologies that you have today require more digital. Why does it require more digital? Today, the network that we know very well, that we have monitors, that we can monitor digitally, is the high voltage network and a part of the medium voltage network. The low voltage network today is not completely monitored. Of course, there has been deployment of smart meters, which has helped to simulate the consumption, but there is still part of the networks that are not monitored. In the world of tomorrow, where you will have more efficiency and more what we call prosumer, it's very important that the grid is connected to those prosumers, because as I explained, you cannot be permanently net zero, right? You have to consume and produce, but it's very important that the network is offering this flexibility. To do that, investment in the network is fundamental. So looking at the energy transition cannot only be looking at renewable investment. It's very important to invest in renewable, but balancing those investments with energy efficiency and the reinforcement of the grid is absolutely fundamental. I think the reports are really here to illustrate that, and if this is not happening, then we will face bottleneck into the energy transition.
Thank you very much. And now I'd like to hand over to Giano Armani, Head of Enel Grids and Innovability. Thank you.
Thank you. Thank you. I will not read, of course. Thank you to the International Energy Agency to shift the focus on the energy transition towards clients and grids. We have been working a lot on how to incentivize the new generation, renewable generation, to facilitate installation, to foster technology development. And now we are in the situation in which renewables are the most efficient, less costly energy to provide to the network. And the acceleration we had from the energy crisis, not that one should desire a crisis, but has been a very strong tool to create awareness about the cost of energy and to accelerate the clients to be actively part of the transition. We are seeing today, as Enel, 50,000 new connections of producers to the grids in Italy and South America, Spain and South America, every month. So we will reach, by the end of the year, more than 500,000 new connections to the grid of new producers. 70% of these have batteries, so they have a way to make flexible their consumption and to modulate the production connected to the grid or the absorption of energy from the grid. This is a huge change in terms of activation of clients. First of all, what we see is that clients not only are more keen to create efficiency in their consumption. Of course, high prices are a big tool for this, but they are also more keen to electrify their consumptions. As they adopt renewables at their house or their condominium, then they adopt electrification of cooking, electrification of heating, and this is a huge shift in the energy mean. They also adopt electric vehicle for the private movements, and this is a transition in terms of consumption. Then, of course, the other element that is crucial and that has not been addressed up to now is grids. Of course, grids are there and they are the biggest habilitator. If incentives are not needed, grids are the biggest habilitator and facilitator for new connections and renewable development, both for hosting capacity, so the availability to be there, plug and play, available for clients that wants to invest on new renewables, but also in habilitating and guaranteeing security of supply over time, even in a scenario in which generation is not concentrated but distributed. Enel has recently presented to the markets its new business plan for the next 3 years and focused on distribution on grids. Most of their investments, more than 18.5 billion euros in the next 3 years, are concentrated fully on grids. Is 53% of overall investments that are in the plan. And this is, of course, a big shift in terms of prioritizing what is the biggest and more effective investments in order to facilitate transition. And investments, of course, are focused on quality of service and connections to clients in consumption, but they are also shifting towards 2 directions that are paramount in this plan and that have been addressed by the report that was presented. First of all, the integration and digitalization of the grids to integrate renewables. We have been moving from digitalization that was focused on having the measures of consumption available remotely in order not to go the home to the clients and being more efficient in acquiring the measures. Then we shifted to automate and the networks in order to resist to blackouts and to reshape the networks in cases of maintenance. We are shifting progressively into a more distributed intelligence in order to manage directly the apparatus and the production that is homed in our clients' houses. And this is, of course, a dramatic shift in terms of investments and in terms of intelligence that needs to be distributed in the network, taking into consideration that has to be very light investments, given the fact that we project more than 5 million of producers in 2030. The other element is we are transforming an electricity grid into the main driver in the main network to provide energy to our society. We are shifting mobility towards electricity. We are shifting heating from gas to electricity, and therefore electricity grid is paramount in any of our life elements. We therefore require more resiliency, and we are immersed also in a climate that is changing and that is more severe in the events, and we need to provide higher resilience to the network in these conditions. These are the two main drivers for change, and of course they require, as the report reports, skilled workers and a supply chain of apparatus that is accessible, localized, and possibly that creates wealth in our economies. And therefore, the partnership between suppliers and utility is fundamental to foster this transition. Thank you.
Now, wonderful. That's obviously very, very insightful. And I think now we have the opportunity to for questions from the room.
Jonathan. I'd like to ask you, what is the biggest challenge facing? What is the biggest challenge facing Enel in terms of expanding the grids?
I don't know if is it working? Yes. Actually is a collective challenge. It's not only to throw money in new investments. Of course, we have challenges in terms of technologies, but we have to shift the sensitivity of the regulators in order to address the main issues that we are facing. First of all, climate change is putting at a challenge all our networks that have been conceived with, let's say, specifications that have, in terms of temperature, wind speed, water, that were completely different from the one that we're facing today. Of course, in specific moments, but they put at a significant hurdle to the networks and to guarantee security of supply. That is create the correct sense of urgency in order to intervene in anticipation before events happened. This is crucial. And secondly, we need to work on digitalization involving a distributed or a wide range of potential actors in terms of contributor to the security of supply, taking into consideration that some tools that have been used in Europe, for instance, like market, are not accessible to this situation. I make an example. Today, most of the big concentrated producers contribute to the security of supply, selling services to the grid. And this is done every quarter of an hour. You issue a price and you are bought to provide a service or not in terms of flexibility. If you projected this on 5 million consumers that are also producers, you cannot have a market tool to provide that. The maximum margin that a single household can have over a year is €5. And nobody is going to work every quarter of an hour on a price for €5 a year. Therefore, you need to have a completely different scheme in terms of infrastructure that you provide to activate that client, because it has to be very cost-light infrastructure, and also in terms of incentives in order to participate to security. This is a completely different world. We need to project our politicians and our regulators beforehand, before this kind of transition is there.
Hi, Yusuf Latif from Smart Energy International. Brian, I have a question for you. You mentioned that there's a lot of progress being seen on policy for energy efficiency, which is great, but almost that energy intensity is in competition with that. Is one outpacing the other? And if so, is that something to be alarmed about? How do we actually prevent that from being another bottleneck in global energy efficiency?
So it's different in different parts of the world. Thank you for the question. And I think the way to address this is more efficiency policy, because in some places they work hand in hand, and in some cases they do push back against each other. And let me give you an example. In some markets we see now energy efficiency policy is making cars a lot more efficient, and of course we're seeing very fast growth in electric vehicles. But on the other hand, we're seeing cars become a lot heavier and SUV sales growing very rapidly, and SUVs tend to be heavier and less efficient, and so in terms of energy use, those issues are competing with each other. And so the solution to that is more efficiency policy and more push for electric vehicles. In other cases, we're seeing the alignment between those issues, but I work in energy efficiency, so my solution to every problem is more efficiency policy.
Thanks a lot. Michael Villa, Executive Director of Smart Energy Europe, the European business organization on demand-side flexibility, and indeed Schneider Electric and Enel are two of the proud members of our organization. Brian, I would like to understand how much of these grid investment are operational investments, because from your presentation I have an understanding that you are focusing more on CapEx, on reinforcement, and which I would disagree. Yes, we needed to make more investment in grids, but not only in CapEx. And I would also disagree on what was said before in the morning during the summit by the CEO of Enedis, who was saying that for every investment in renewables, we need to make the same investment in grids. If we are thinking in a scenario where we are going to have more decentralized renewable generation, more prosumers, and also communities developments, they would self-balance or self-consume that consumption of renewable generated on-site or in a decentralized way that will avoid stress, congestions to the grid. So the importance of the grid is to use the flexibility of the connected active consumers or prosumers to then that would require indeed OpEx more than CapEx. How this story is fitting into your narrative? Thanks.
Pablo, you may want to comment on that, but just from my point of view, and thank you, Michael, for the question, but the nature of energy efficiency is certainly changing in the context of the remarks you're making, because we're no longer in many electricity systems interested in how much energy that washing machine uses over the course of a year, because there's times when electricity is super clean and super cheap because renewables have penetrated really well. But a couple of hours later, that same washing machine is using power that's very expensive and very polluting. And so the flexibility and the responsiveness of our demand is really, really important now. And we think about energy efficiency in a much more dynamic and holistic way. And so thinking about what digital technologies can do to make responsive and flexible systems is really important. And thinking about efficiency in a much more holistic way and systems-wide way is really important. And policymakers are starting to think in that more dynamic way, and in the way that digitalization can really squeeze more out of grids, but also operate grids in a much more future-looking way is a really important point. Pablo, I don't know if you want to add to that.
Yes, gladly. Is this working? Yeah. Thanks for your question. So, first of all, I would like to think a bit globally. And when we look globally, what are the drivers for development of grids? And integration of renewables is not the first driver for development of grids. It's economic growth, it is access to electricity, it's new sources of services, be it air conditioning, be it heating, etc. From this perspective, grids play a central role for enabling that as the first steps, and of course from the perspective of security. Now, the second point is related to what you mentioned. Yes, indeed, we see a significant role for distributed services, for the possibility of utilizing microgrids. And the numbers that you see when we're talking about the need for 80 million kilometers of grids being strengthened or advanced are considering a significant shift in the nature of the utilization of the power systems. At the same time, distribution grids play an enabling role that is essential for all of these technologies. When we're talking about communities that are prosumers, for example, the reality is that the adequacy needed for serving those consumers will still be there. So even if we look at the yearly consumption of electricity being 80% lower, the peak demand that needs to be able to be provided and brought from these new distributed resources to the consumer might be the same, unless you're talking about a completely isolated system. And from the perspective of compromising security, it is very clear that security needs to be kept as a first priority if we're not to endanger energy transitions. Now, when we're talking about CAPEX versus OPEX, I do agree there needs to be a focus on OPEX as well. But again, from the global perspective and looking really at the development of the world, when you look at the growth of new transmission lines and distribution lines, this is mostly emerging economies. And these are places where really the challenge is driving that financing, driving that investment, and dealing with the economic growth and the growing population. So there is a role, but of course there are local flavors where you might see some issues that are a bit more prevalent in some regions than others. Thank you very much.
Hello, I'm Alistair Morphy from Cambridge Consultants, which is an engineering design consultancy. In 2022, the average electricity consumption in the UK was 37 gigawatts, which is about 16% of our primary energy consumption. As we try to move towards a net zero energy economy in 2050, what percentage of energy transactions do you think will be electric in 2050? And do you think we'll be able to generate that much net zero electricity locally in our countries, or will it require large amounts of imports? And that ratio of 16% is very similar. I've given the example of the UK, but the ratio is very similar for most European countries.
I mean, I won't comment on UK-specific numbers because, to be honest, these are political decisions as much as technical decisions, because we certainly see that it seems that most countries, every country has decisions to make on its pathway to net zero, but it seems that electrification is a more rational pathway for most countries because penetration of renewables is going really well. Prices have come really, really down very successfully, first in onshore wind, then in solar, now in offshore wind. And we have seen really great success on some of the demand side of electric technologies, electric vehicles, heat pumps, others coming on board. So electrification does seem to be central in terms of a technological progress, and then we do see it being put centrally in terms of policy progress. And therefore we do see absolutely that clean energy supply will have to grow. Whether that is in a more decentralized or centralized model becomes a political decision. And whether that becomes more in terms of more householders generating in a distributed way, more kind of interactive grids in terms of the place of electric vehicles as sources of supply and storage, or maybe people are thinking more in terms of transmission models and Northern European supergrids. All of the things are being debated. They'll have to win out in terms of their technical feasibility, their economic viability. I don't think it's something that we have a formal position on, because ultimately it will be for government to decide which path to take. I think that technology is opening up possibilities here in terms of balancing supply and demand with storage in the middle, and of course not neglecting, as we're discussing here, flexibility. There are options on the table that really were not on the table even just a couple of years ago. So I think there are many more options available to societies and governments than ever before.
Since it was not a targeted question, I'll just jump in a bit. I completely agree with what you say, Brian, and Indeed, the pathways of the future are policy decisions. What we see looking at the past few years is that the growth of electrification is hard to stop. And there's a very strong rationale for that. There's a very strong economic background for it. And it means that electricity really is today the beating heart of modern economies. Now, when we're looking at the perspective of regional integration, which is something you mentioned, again, it is a policy decision, but what we have seen globally, and this applies for advanced economies, emerging economies, is that the interconnection of power system brings significant benefits in security, brings significant benefits in terms of affordability, and of course it can provide a strong leverage and foundation for the flexibility needed to further integrate renewable resources. So again, electricity development pathways, like Brian says, very much policy decisions, but there are very strong economic motivations that have driven historically until today the growth of electrification that we're seeing.
Thank you. Camilla Nashat from S&P Global Commodity Insights. I wanted to talk about supply chains, because you mentioned that securing supply chains and grids is really essential. And the IEA has previously warned that parts of the renewable supply chain are too concentrated in certain countries where a lot of the manufacturing is based. What does that look like for grids? Do you see a similar situation there? Maybe you can talk specifically about certain components. And then maybe to Enel also on the grid supply chains, are you seeing a price inflation there in the last year or so? If maybe you can quantify what that looks like, what that means for the business case?
Look, on the on the supply chain, so we need to look at what has happened, right? Post-COVID, there has been tension on almost everything, including tension on logistics, basically. We're out of this period, right, where there is overall tension on the supply chain. Now the electronic components are available, and the logistics scheme is, I would say, back to normal, more or less. What has happened, however, is that there are some components that were where the demand in Europe was not enough to manufacture, okay? And those components have been moved at large to Asia. We are not too much concerned by that at Schneider Electric because we produce medium voltage components, and basically our supply chain is regional. Okay, so we produce in Europe for the European market, we produce in US for US market, we produce in China for China market. Now for some technology like high voltage transformer, some sorts of cable and things like that, there is not enough today supply chain in Europe. And here, as you say, is a political decision. Okay, it cannot be just the profession, it's a political decision to decide to reshore those technologies that are essential for the grid of the future. And by the way, as much I see policies on semiconductor, on pharmaceuticals, there need to be a policy on reshoring of critical components for the grid of the future.
The question you are posing is crucial, as a matter of fact. It's crucial for the success of the energy transition. We have been dependent in the last year from supplies that were coming from far away, particularly on small components and less technology-intensive components. Some pieces of the value chain, like transformers, have been completely dismantled in Europe, even though we had the best producers in the world. And therefore, we have to think to reshape and reform. We need to have, of course, some aid from policymakers because these are global value chain, and they need, if you need to reshore it, you need to have specific policies like in the US they are doing. We have been contributing, for instance, on panels that we were the first developers as Europeans, and then we completely dismantled. This is also due to the let's say, change in dramatic change we had in incentive schemes over time that, of course, disrupt the value chains that we built. There is also another shortage that is on professionals. We find that it's harder to find technicians, electricians that are able to work on the networks, and this is something that is paramount in order to install and let's say improve the networks that is so wide in terms of reach. Lastly, of course, we have seen a significant rise in terms of prices. Of course, energy impacts all the commodities and therefore most of the components in the grid. And this is factored also in our business plan. We need to work with suppliers in order to improve our designs. We are coming from a culture in which utilities were defining their standards in order to facilitate maintenance. Standardization is very strong in and creates efficiency in people management and also stock of items. We need to shift this in terms of working more with suppliers in order to understand what are the limitations and what can improve their cost of production in order to reduce the cost of items. And this is a shift also in frame of mind that we need to improve in our companies.
Hi there, Kevin Clark, Power Engineering in North America. I just wanted to ask you, Frederick, wanted to touch on the resiliency component for a second. What are you all at Schneider doing to increase resiliency for your customers in the face of increasing extreme weather events? Thank you.
Well, resiliency is a lot of mix of hardware and digital, right? If really, and especially you speak about extreme weather event, a large part now of the anticipation and the reaction to extreme weather events starts by digital. Okay, of course, move to hardware at one moment because if the line is down, the line is down. You need to rebuild the line. The big difference with electricity and telecommunication is that electrons are not flying in the end. If the line is down, you know. But if you look at digital technology, in time of someone that I would say better than me, but you restore many customers just with digital. And the more your network is instrumented, the more possibilities you have to build a resilient network, okay? But at the end, physics matters as well, right? If the components are down, you need to replace the components. But digital help a lot, drive the team to the right place, because, you know, you need to have the intervention team going at the right place at the right speed. Here, digital is essential. And by the way, when we were this morning discussing with the profession, everybody is now using digital technology for resilience purpose.
One more question. Hi, Dila Jibiji from Inspiration in London. I had a question also in light of the supply chain question that's been asked earlier. In terms of the collaboration between stakeholders, private as well as public, I was wondering what would you like to see happening there and what might be the challenges and how would those be resolved potentially? Thank you.
Thank you very much. It is a very good question. How can we really scale up and create resilient supply chains? And I'm sure that my colleagues from Schneider and Enel will have their own thoughts on that. But generally speaking, what we see is a need to create clear, transparent, and firm pipelines of projects. When we're looking at the supply chain, and if you look a bit at the figures of the analysis, you will see that we require a significant scale-up in the provision all the way from minerals like aluminum and copper to components of transformers themselves, power electronics. And in order for the scale-up to take place across the entire value chain, we need to see projects being proposed, being firmed, and being transparent to minimize the risk that the supply chain stakeholders will face. And as we know, risk is equivalent to a risk premium, and that means that it's also a challenge in terms of the affordability of the transition. From that perspective, there's a significant part that regulators can play in terms of how to maybe change the paradigm that they have when you're planning future-proof grids and projects, particularly considering the very long lead times that these projects have. And in that way ensure that not only the grids are there when they're needed, but the entire supply chain and sub-supply chain associated to those projects will be able to be ready at an affordable and resilient place. But I'm keen to hear your thoughts.
A few more elements on what built a resilient supply chain. You need two things, right? You need of course, the economic parameters right, so some visibility on price and cost, okay? The energy crisis, and you mentioned it, Gianni, has been a bit of a hiccup, but we consider is the past, probably not the future. The second thing you need is prevision, is forecasting to adapt your supply chain. We were with the profession of transmission and distribution supplier in Brussels 1 year ago when the European Commission said, well, look, the grid need to be reinforced. It will be time to. For us, is a great help, right? Because to build a factory, 18 months, count 18 months, okay? So if the demand suddenly rise without forecasting, you cannot react. Okay, you can react if you have prevision that are reliable. And today, in grid, we have prevision. By the way, today, we are investing ahead of the curve in many things because we want to be ready and we don't want to be the one blocking the energy transition.
As a continent, we have a clear competitive advantage that is the cost of capital, even if has been risen. We need to create stability also in the demand in order to guarantee that a supply chain is stable and facilitated. Because if we have a stable demand, we can attract investments more effectively than other places. In order to have stability in terms of demand, we need to have stable regulation. That is very important because in the condition in which the crisis has driven up the interest rates and inflation has been hitting most of the sectors, regulation has to adapt, of course, in terms of with common sense to the new situation in order to stabilize these effects. The good thing is that we have a clear polar star that leads our efforts, and if we have clear what is the direction, then it's more easy to adapt the regulation in order to surpass the hurdles that are there.
Okay, that's all we have time for. Just one last reminder, all content is embargoed till 7 a.m. tomorrow morning, and obviously then the full report will be available, so please bear that in mind. I think we should thank all the panelists here. It's been very interesting, and thank you very much for your time as well.